This video is over the conservation of energy. So first we're going to start by talking about fire. So fire is just the result of a chemical reaction. It's actually a combustion reaction. And later on in this chapter, we're kind of look further into the whole combustion reaction. So when heat is applied to a gaseous hydrocarbon, and hydrocarbon is just a fancy term for a compound containing both carbon and hydrogen, the bonds within that hydrocarbon are going to break, and then they're going to reform with the oxygen that's present in the air, and then it's going to produce new molecules of carbon dioxide and water. And then during this whole combustion, heat and light are released. Okay, so the heat energy released is greater than the heat energy needed to begin the combustion reaction. Okay, so a flame, therefore, is made of both matter and energy. And so we're going to talk about the different forms of energy and how energy is conserved. So the law of conservation of energy just states that energy cannot be created or destroyed, just like matter. Okay, it just changes form. And so here are the 6 basic forms of energy that we're going to focus on. So we have radiant energy, which is light energy. We have thermal energy, which is heat. We have chemical energy, which is the energy that's stored in chemical bonds. We have mechanical energy, and so this is a combination of both potential and kinetic energy. Kinetic energy is the motion, or the energy of anything in motion. So this is movement, basically. Electrical is the energy that's produced when electrons are moved from place to place. Okay, and then nuclear energy is the energy stored inside of an atom. So like splitting atoms would produce nuclear energy. Okay, so we're going to do a few practice problems. Some of this should be reviewed from your physical science class that you had before, the transforming of energy. Okay, so when a flashlight is turned on, a flow of electrons is created by the batteries. The electricity passes through the incandescent light bulb, causing the tungsten filament in the light bulb to heat up. When the metal is hot enough, photons of light are emitted. Okay, so we're going to start with chemical energy. So chemical energy is the energy stored in the battery. Okay, and that is going to be converted into electric energy, okay? Because when the flashlights turn on, the flow of electrons is created from the battery. So the battery, before it's turned on, is chemical energy. When turned on, it's going to allow the electrons to flow. So we've gone from chemical to electrical energy. It's going to pass through the incandescent light bulb, causing the tungsten filament light bulb to heat up. So we're going from electrical energy to thermal energy because it's heating up that tungsten filament. Okay, when the metal is hot enough, photons of light are emitted. So we're going from that thermal energy, the heating of the tungsten, into radiant energy because it's going to actually light up. It's going to produce photons of light. Okay, so we went from chemical to electrical to thermal to radiant. Okay, for the next one, in a thunderstorm, positive charges build up underneath clouds and negative charges build up along the ground. Eventually, a current of lightning connects the two. The heat from the lightning causes air to move, producing sound of thunder. Okay, and this is actually going to utilize one of the forms of energy that we didn't really talk about, but I'll kind of let you know what we can utilize here. Okay, so we start with lightning connecting the two charges. So the electrons are going to be moving, so it's going to be electrical energy. Okay, and then it's going to heat the air, so it's going to be converted to thermal energy. And then it's going to cause the air to move, producing sound or thunder. Okay, so this is going to be, you could say sound energy, but if we look back at ours, we didn't have sound energy, but it says it's the movement of air, so it is mechanical, okay? And if you remember, or if you did talk about waves in your physical science class, mechanical waves are the motion of particles, okay? So sound waves are mechanical waves. So we went from electrical to thermal to mechanical. All right, and then the last one, in an explosion of dynamite, chemical energy is transformed into, okay, we're going to have thermal energy that's produced. We're going to have radiant energy potentially, okay, so it's going to produce a light, and then also mechanical energy. Okay, so that mechanical energy is going to produce sound.